pre-test answer. 1. When two elements form a bond equals their pair energy is decreased. 2. A bond formed between carbon and chlorine will be equals polar covalent. 3. Which of the following elements can have a less than a complete octet equals boron? 4. What is the correct Lewis structure for carbon monoxide equals C has 2 dot on top double bound to O with 4 dots? 5. From left to right, what are the formula charges on each atom in Lewis structure shown below? Equals O equals 0, S equals +1, O equals -1 because V is VE, LP parenthesis 1/2 B, so VE is valence electron, LP is lone pair, and B is bond electron. So we put the amount of each of the thing to get our answer. 6. What is the electron group geometry aka Ig, molecular geometry aka Mg, and hybridization for ammonia? BF3 equals Eg is trigonal planar, Mg equals trigonal planar, and has sp to the square root. 7. What is the hybridization of the central atom in HCN? Dual Lewis structure equals sp. Because H equals 1, C equals 4 and N equals 5, so there be a single bond on H and N, 2 dot on N and double bound on N, and C may be 2 dots on C. 8. According to valence bond theory, what valence orbitals overlap, and what type of overlap occurs to form the N single bond to H bond in NH3 equals H1s, nitrogen sp3, and side to form pi bond because it forms a tetrahedral shape, basically a T shape, and N has 2 dot on top. 9. Which of the following bonds will be shortest? Equals C single bond to H and also N single bond to H. 10. How many pi bonds are found in CO2? Use Lewis structure equals 2 because it forms a linear shape, it's double bound to C and both O has 4 dots. 11. Draw the Lewis structure for the compound formed between O. Use the line arrow to show the dots going other element, example magnesium and nitrogen, to figure out how many dots. Use the round number from the top going left to right. So Mg has 2 and nitrogen has 5. Also the ionic charge for Mg is 2 and N is -3 because ionic charge only work from 1 to 3 and 5 through 8, but with certain element has different ionic number. 8 equals 0, so He through Rn equals 0. 7 equals -1, so Fe through I equals -1. 6 equals -2, so O through Se equals -2. 5 equals -3, so N to P equals -3, while 3 has only L and G, 2 has Zn, Cd, B through Ra, and 1 Beg, H through Fr. So we need 3 milligrams because N needs 8 to be polar, so we have 2 N because we have leftover dots. Then form as 3 milligrams to the square root and 2 square bracket the Lewis structure for N inside and a 3 negative root outside the square bracket. Also sodium and sulfur, we have 1 in cesium and sulfur has 6, meaning there are 2 Na and 1 S because it only need 2 more dot to be polar. So the element compound be 2 Na to the square root plus and square bracket S dot structure and the 2 minus on the outside of square bracket. 12. Draw the Born-Haber cycle for the formation of alkyl 3s. So this on has the 2 ionization of the element adding to each other with up arrow below, having the element go down 1 less ionization, or the amount in element with state of the element with another up arrow below go down another ionization or amount of element and state of element. but you need to put IE1 at the first ionization and triangle FH times amount in second element. Then IE2 is placed for the second ionization and triangle EAH times amount in second element for the completed second element, and continue the IE if there is still more ionic charge for the other element. For example, we need to get the formula to get AlCl3G, so we has Ls plus 3 times 1/2 Cl2, then going up is Alg plus 3 Cl, then up arrow Alg first ion, then do this 2 more time to get a total of 3 ions for Al plus 3 Cl, then draw going down to the alkyl 12b. Calculate the lattice energy for alkyl 3s given the following. The amount of the element should be given, so use formula triangle lattice. So we have our triangle lattice equals triangle H atom minus IE1 minus IE2 minus IE3 if there is one, if not minus parenthesis amount in second element times triangle RH parenthesis minus amount in second element times triangle EAH parenthesis equals answer in kJ over mol. 13. Consider the following compound. Two compound elements that are together. This uses logic where the closer the two bonded element is, the stronger the element is, and farther it is the weaker it is. Example: MgCl2, Cas, Ki, NaClBaCl2 in order of decreasing lattice equals Cas is greater than MgCl2 is greater than NaCl is greater than Na is greater than Ki is greater than BaCl2, the compound that is highest boil and greatest solubility. 14. Complete the following table. Show lone pairs and enon's row charges on atoms where they apply. So number of electron group 2 is 4 linear, which has 180 degrees, also is sp. Number of electron group 3 is trigonal planar, which has 120 degrees, and if there's a lone pair it's bent 120 and is sp to the square root. Number of electron group 4 is called tetrahedral, it has 109.5 degree. But if it one lone pair it's called trigonal pyramidal, and of it has 2 lone pair it's called bent 190 and is sp3. Number of electron group 5 is called trigonal bipyramidal, has a 90 and 120 degrees. If it has 1 lone pair it's called seesaw, if 2 lone pair it's called T-shape. And if 3 lone pair it's called linear, also it's sp to the root 3d. And 4 number if electron group 6 is called octahedral, if 1 pair it's called square pyramidal, and if it had 2 it's called square planar and has sp to the root 3d to the square root. For 1 with element compound, put amount of element in for the Lewis structure. If element compound has a negative root, the Lewis structure be in a square bracket with the root out the bracket. Example: BrCl4 to the negative root, so we get the amount of dot in element at if it's negative or minus if it's plus. For the Lewis structure is shaped as a plus and B has 4 dots and 4 single bond to 4Cl with 6 dots with the negative root inside a bracket with negative root on the outside. For electron geometry it's octahedral. Molecular geometry is octahedral and hybridization is sp3d2 because it's octahedral. So our amount of dots for the element is 6 plus 16 times 3. For the Lewis structure it going to be a T-shape, but 1 the O I believe is going to be doubled bound. The electron geometry is trigonal planar. The same goes for the molecular geometry, and the hybridization is sp2 because it's trigonal planar. ClF4 to the plus root, so the amount in element, so 7 plus 7 times 4. 1 to get total amount, and the Lewis structure is a plus shape with the plus root inside a square bracket with a plus root. Electron geometry is trigonal bipyramidal, and molecular geometry is also. The hybridization is tetrahedral sp3d. 15. For each molecule shown below NH3, ICl4 to the minus root and BRF3, calculate the bond polarity based on electronegativity values and designate as polar and nonpolar. Draw any resulting overall molecular dipole moment as an arrow with the arrowhead pointing toward the sigma, aka upside down capital Q end of the dipole. If there is no overall dipole, write no dipole. Lone pairs are not shown for clarity. To explain, you draw arrow to the most negative charge element, which is given also minus the 2 element. Also to clarify if it is polar or non-polar, these number are also given. Also if arrow go opposite direction it cancels, means no dipole, and if both go the same direction it combines, or if we still have arrow it had a dipole. Example NH3, since N is more negative it is polar because there is an arrow going up, and 3 minus 2.1 equals 0.9. ICl4 is non-polar because the arrows go towards Cl and go into a different direction, meaning it doesn't have a dipole moment. And BF3 tail arrows go toward F, leaving one arrow going left, it's polar, and 4.0 minus 2.8 equals 1.2 is the answer. 16a. Draw 3 resonance structure for the sulfate SO3 He negative square root ion. Show lone pair and Enninen's row formula charges on atoms where they apply. Explain this element has 3 way of being formed, so we draw it those different ways. Example square bracket O, which has 6 dots and a single bond, to S, which has 2 dot and has a double bond to another O and a single bond to another O, which both have 6 dots. Close the bracket and place the negative root out the bracket and draw 2 different version of this element with the double bond change between the O. Also 0.1 to 0.4 is non-polar, 0.4 to 1.8 is polar, if O it's pure, and over 1.8 I believe is ionic. 16b. Draw a resonance hybrid structure for SO3 to the negative square root ion based on the 3 resonance structure. Include any charges on atoms where they apply, taking into account the effect of resonance. Explain you combine all 3 structure in 16a, but for the double bound one line is dashed because of the potential of that bond being the double bond, and add the root charge out the bracket, but it be in a fraction or simplified, so since this one has 3 possibility that be at the bottom and it minus 1 because 1 these O will because a double bound, making it negative 2 over 3 is our root. 16c. Calculate the S single bond O order in SO3 to the negative square root. Explain it uses the formula shared electrons divide by the number of S single bond O. Example, there are 8 shared electron between all O, and there are 2 set of single bond from O to S, so 8 divide by 2 get 4, but we have 3 possible O that can be single bonds, so we divide 4 by 3 to get 1.5 for the answer. 17. Calculate the enthalpy charge, which is triangle RH, for the reaction below using bond dissociation enthalpy. Start by drawing Lewis structure of the reactant and product. Explain you draw the Lewis structure and note the difference from reactant and product because of bond broken minus bond formed. Example CO2 plus 2HF equals H2O plus COF2. So when you draw out the Lewis structure, all but COF2 is linear and COF2 is T-shape. But the difference coming by looking at CO2 and COF2, you notice that it keeps the C in the middle, however had 2F, and same for 2HF and H2O, it keeps the 2H but not what in the middle. So we place the amount of the element like so, square bracket 745 plus 2 times 565 end of bracket minus bracket 2 times 463 plus 2 times 485. We do this because there are 2 in each end atom but C. 18. Based on the Lewis structure of H2O shown below, show how you would derive the valence hybrid orbitals around the central atom from its original valence orbitals. Start by using the template below and label the hybrid orbitals that you form after arrow. Fill the orbital with electron from oxygen only and indicate which orbitals are involved in sigma bond, aka upside down capital Q, and which contains lone pair. Explain the first element will use the orbital 1s, 2s, 2p, 3p, 3s, 3p, 3d, 3s, 4s, 4p, 4d, and 4f. The amount electron in each goes s equals 2, p equals 6, d equals 10, and f equals 14. Example: fill in the last 2 orbital of the element. Remember to fill arrow up before putting the down in each orbital box. Example: NH3 has 3H single bond to N with 2 dots on N. The valence orbital for N has full 2s orbital and 2p is only filled with 3 up arrows. The 2p orbital are involved in sigma boning as the 3 hydrogen atoms O is orbitals. While 2s orbital contain lone pairs, the NH3 structure is based on nitrogen atomic number 7 with the electron config B1s to the square root, 2s to the square root, and 2p to the third root. It be a sp3 hybridization because it has 4 electron group and nitrogen undergoes sp3 hybridization to form 4 sp3 hybrid orbitals, and among these 3 sp3 hybrid orbitals linearly overlaps with his orbital electrons of atoms to form 3 sigma bond, aka upside down capital Q. While 4th sp3 hybridization contains lone pair of electrons. Thus as Lewis base, so the lone pairs are the 2 dots on N and the sigma bond are on the single bond from H to N. 19a. Draw valence molecular orbital Mo diagram for molecular oxygen O2 and the superoxide ion, O2 to the negative root. Explain: so we have 2 hexagon inside one another. On the outside of the big hexagon we have 2p on the left and right, and on the top is sigma to the root times 2p 2 parentheses u parentheses, and bottom is sigma 2p 2 parentheses g parentheses. As for the hexagon, on the inside are 2 boxes both on top and bottom. The top, the first box is pi 2py and the second is pi 2px parentheses g parentheses. As for the bottom, the first box is pi 2py and the second is pi 2px parentheses u parentheses. 2 more hexagon are there. The one below the double hexagon had 2s on the left and right, and on top is sigma to the star root 2s parentheses u parentheses, and bottom is sigma 2s parentheses g parentheses. Then below that is the last hexagon with left and right having 1s, and the top is sigma to the star root 1s parentheses u parentheses, and bottom is sigma 1s parentheses g parentheses. This more a long way of doing electron config for the element with sigma or pi. Example O2 has 16 electrons, so the sigma order is sigma 1 Sg, sigma to the star root 1 Su, sigma 2 Sg, sigma to the star root 2 Su, sigma 2 P2G, pi 2 Pyu, pi 2 Pxu, pi to the star root 2 Pyg, and pi to the star root 2 Pxg. All but the last two have 2 over the sigma or pi, but the last two have 1 on both pi because there are only 1 arrow on those while the rest has 2. As for O2 tot he negative root equals 17 electrons, making the sigma order to be sigma 1 Sg, sigma to the star root 1 Su, sigma 2 Sg, sigma to the star root 2 Su, sigma 2 P2G, pi Spyu, pi 2 Pxu, pi to the star root 2 Pyg, and pi to the star root 2 Psg. All but the last one has 2 over sigma and pi, but the last pi has 1 because that one has a lone electron. 19b. Based on the Mo diagram, calculate the bond order for O2 and O2 tot he negative root. Explain bond order equals 1/2. Square bracket bonding electron, anti-bonding electron bracket. The bonding is sigma of electron config and the anti-bonding is sigma to the star root the electron config. Example: so O2 has 1/2 square bracket 10⁻6 bracket because all the sigma and pi without the star root add to 10, and same with all sigma and pi with star root add to 6, but it equals 2. For O2 to the negative root equals 1/2 square bracket 10⁻7 bracket equals 1.5 because there is one more in the star root. Bonding and molecular structure worksheet. Draw the Born-Haber cycle for the formation. At top get the full ionization and amount for both elements so it could get the completed element equation. Having a up arrow, put this below it have half ionization and amount for the element. Again put up arrow and below it put the proper state the element is in. Last up arrow and below putting the formula that is want is to draw. The first element should always turn to a gas. X, Ba to the square root and his would be IE2 and add 2Cl to the negative root 1 would be the amount in that element times triangle AH. Below the up arrow IE1 is Ba to root plus G, while amount in element is 2 times triangle H of element and triangle H of the formation element. Below IE1 would have triangle H atom of element. Calculate the lattice energy. Each thing should be given, but for the formula for triangle H lattice equals triangle H formation, triangle H atom for first element in formation minus IE1 first element minus IE2 first element minus parenthesis amount times triangle H the second element in state. Parenthesis minus mount times triangle EH. H the second element parenthesis equals Kj/mol. Also triangle H of compound minus triangle H first element minus IE1 first element minus triangle EH. H second element. Left to right in order of increasing lattice energy, so left is small while going right is getting larger. Using E equals KQ1 times Q2 divide D2, so Q is charges on ions and D is distance between ions. Draw the Lewis structures of the following ionic molecules. Element is amount on in up and down the row and put amount into the other element to make it stable, but the first element is in square root and 2 times the second element to the amount needed negative root. Draw the Lewis structures of the following covalent molecules. CHCl3 uses V, E, which is the rows on top of the element is the amount it has, so C equals 4, H equals 1, CL equals 7, so you arrange it like C plus H plus parenthesis 3 times CL, because there is 3 CL in this structure, so you times the amount of whatever is in the third element in structure. Determine the molecular geometry and angles. PCl5 Ig equals 5 BP and 0 LP. Trigonal bipyramidal look like starfish. BRF5 Ig equals 5 BP and 1 LP. Square pyramidal look like leaf shape. XEF4 Ig equals 4 BP and 2 LP. Square planar look like cross. As F4 Ig equals 4 BP and 1 LP. Seesaw is cross but has brackets around and a negative root. Chlorine trifluoride Ig equals 3 BP and 2 LP. T-shaped looks like an upside down T. I3 to negative root, also known as triiodide ion, Ig equals 2 BP and 3 LP. Linear is just a straight shape. Psi F6 to the negative square root Ig equals 6 and 6 BP. Octahedral is shaped like a open up head scratchier and in square brackets and has a negative square root. CHCl3 is tetrahedral. C and O in H2CO3, while C is trigonal planar and has 3 Ig and 3 BP, but the O has Ig equals 4 and 2 BP and 2 LP is bent 109. Bromine dioxide Ig equals 2 BP, 1 single electron bent 120. So 4 to the negative square root Ig equals 4, so 4 BPO LP tetrahedral. Po4 to the negative 3, same as last problem. BH4 to the negative root, same as last problem. No 2 to the negative root Ig equals 3, 2 BP 1 LP bent 120. BP is bond pairs and LP is lone pairs. Determine the molecular polarity of all molecules. PCl5 is non-polar. BRF5 is polar. XEF4 is non-polar. As F4 to the negative root is polar. Chlorine trifluoride is polar. I3 to the negative root is polar. Psi F6 to the negative square root is polar. CHCl3 is polar. C and O atoms in H2CO3 is polar. Bromine dioxide is polar. So 4 to the negative square root is polar. Po4 to the negative 3 polar. BH4 the negative root is polar and no 2 to the negative root is polar. Determine the bond order. PCl5 equals 1. BRF5 equals 1. XEF4 equals 1. As F4 to the negative root equals 1. Chlorine trifluoride equals 1. I3 to the negative root equals 1. Psi F6 to the negative square root equals 1. CHCl3 equals 1. C double bond O is 2, C single bond O is 1, O single bond H is 1. Br single bond O is 1.5. So 4 to the negative square root equals 1.5. Po4 to the negative 3 equals 1.25. BH4 to the negative root equals 1. No 2 to the negative root equals 1.5 is the answer. Arrange the following from shortest to longest. Draw need-Lewis structure, so for this it's 4 no 2 to the plus root or no plus root, so 4 no 2 to the plus root is linear shape in a square bracket equals 2 since it's a double bond, and no plus root equals 3 because it's a triple bound. And NH2O looks like a bucket with a nub on the left side equals 1. Also do VE for each one, and bond length decreases with increasing bond order, so shortest to longest N single bond O bond length would be no plus, no 2 plus, and NH2O. Arrange the following from shortest to longest. Bond length increases with increasing size of atom, so for this example N single bond O, N single bond S, and N single bond Se. So in size O smaller than S and then S is smaller than Se, so the order be like how the question but them N single bond O, N single bond S, and N single bond Se. Use bond dissociation enthalpies to calculate the enthalpy of formation. Do formation reaction for this formation, so for example we need to get NH3G, so we have 1/2 N2G plus 3/2H2G equals NH3G. Triangle FH equals sum bonds broken minus sum bonds formed, so it be 1/2 parenthesis D for N triple bound N parenthesis plus 3/2 parenthesis D for H single bond H parenthesis minus 3 parenthesis N minus H parenthesis. Then place the amount for what's in the parenthesis, so D for N equals 945 kJ/mol. D for H equals 436, and N single bond H equals 391 to get the answer in kJ/mol. Chapter 9. Determine the hybridization of the central atom for each of the following molecules. Example: PCl is shaped like flower, Ig equals 5, it has 5 BP and 0 LP and is a trigonal hybridization on P. SF6 is open head starchier or clam open slightly titled to the left, Ig equals 6, it has 6 BP and 0 LP. The shape is octahedral, so the SP to the 3 root and D to the 3 root hybridization on S. So 4 to the negative square root, the Ig equals 4, it has 4 BP and 0 LP, it has tetrahedral, so SP3 hybridization on S. This shape is in a square bracket with the square root over the square bracket. Po 4 to the negative 3 root, it has Ig equals 4 and 4 BP and 0 LP, also the shape is tetrahedral, so SP to the root 3 hybridization on P, it also in square bracket, and HS the negative root over the square bracket. No 2 to the native root has Ig equals 3, also 2 BP and 1 LP, its shape is tetrahedral, so SP to the 3 root hybridization on N, which in a square bracket and the negative root is on the square bracket. Determine the hybridization of each atom, and draw the bonding using valence bond theory. Remember to label the sigma and pi bonds. Example: HCN, so H equals S, C equals SP, and N equals SP, so diagram will have a triple bond between C and N consisting of sigma bond via end-to-end overlap of CSP orbital and NSP orbital, plus 2 pi bonds formed by side-to-side overlap of unused p orbitals on C and N. The H is bonded to C via sigma bond formed by end-to-end overlap of HS orbital and CSP orbital. No 2 to the negative root, the central N is SP to the square root. The O is double bonded to N is SP to the square root, and the other O single bonded to N is SP to the third root, and the CHCl3 all element in this compound is SP to the third root, and the diagram will have 3 sigma bonds formed by end-to-end overlap of CSP to the third root and ClSP to the third root hybrid orbitals. H is bonded to C via sigma bond formed by end-to-end overlap of remaining CsP to the third root orbital and HS orbital. Bf3 so B equals sp to the square root, F equals sp to the third root and 3 sigma or capital Q upside down bonds formed by end-to-end overlap of Bsp to the square root and Fsp to the third root hybrid orbitals. Use molecular orbital theory to determine the bond order of the following bonds. Example He single bond He so the valence Mo electron configuration is parenthesis upside down capital Q1s parenthesis and parenthesis upside down capital Q with a times root with 15 parenthesis to the square root and bond order equals 2 to 2 /2 equals 0. N single bond so valence Mo electron configuration is parenthesis upside down capital Q2s parenthesis upside down capital Q to the times root 25 parenthesis to the square root parenthesis upside down Q2p parenthesis to the square root parenthesis pi 2p parenthesis to the fourth root parenthesis pi to the times root 2p parenthesis to the 1 root, and bond order equals parentheses 8 minus 3 parentheses divide by 2 equals 2.5 answer. B to the single bond N so the valence Mo electron configuration is parenthesis upside down capital Q2s parenthesis to the square root. Parenthesis upside down capital Q to the times root 2s parenthesis to the square root parenthesis upside down capital Q2p parenthesis to the square root parenthesis pi 2p parenthesis to the square root and bond order equals parentheses 6 minus 2 parentheses divide by 2 equals 2. C to the single bond so the valence Mo electron configuration is parenthesis upside down capital Q2s parenthesis tot He square root parenthesis upside down capital Q to the square root 2s parenthesis to the square root parenthesis pi 2p parenthesis to the fourth root and bond order equals parentheses 8 minus 2 parentheses divide by 2 equals 3. Order the bonds in Q3 from strongest to weakest. Answer C single bond O is greater than N single bond O is greater than B single bond N is greater than He single bond He. Draw the Lewis structures of the following molecules from Q3, and compare the bond order to your answers in Q3. Do they match? Bn Lewis structure B and N is a triple bound and N has 2 dots and bond order equals 3/1 equals 3 so no this does not match. Note Lewis also does not predict that Bn is paramagnetic parenthesis Mo diagram has 2 unpaired electrons in 2p Mo parenthesis. Also Co is a triple bound both C and O have 2 dots and bond order is 3/1 equals 3 so yes this matches. Note Lewis structure puts +1 formal charge on O and -1 formal charge on C. Use molecular orbital theory to predict the bond orders and whether the following molecules will be diamagnetic or paramagnetic. Example B2 has valence Mo electron configuration is parenthesis upside down capital Q2s parenthesis to the square root parenthesis upside down capital Q to the star root 2s parenthesis to the square root parenthesis pi 2p parenthesis to the square root and bond order equals parentheses 4 minus 2 parentheses divide by 2 equals 1 also is paramagnetic. C2 has valence Mo electron configuration is upside down capital Q2s parenthesis to the square root parenthesis upside down capital Q to the star root 2s parenthesis to the square root parenthesis pi 2p parenthesis to the fourth root. And bond order equals parentheses 6 minus 2 parentheses divide 2 equals 2 also is diamagnetic. NF has valence Mo electron configuration is upside down capital Q2s parenthesis to the square root, parenthesis upside down capital Q to the star root 2s parenthesis to the square root, parenthesis pi 2p parenthesis to the fourth root, parenthesis pi to the star root 2p parenthesis to the square root. Bond order equals parentheses 8 minus 4 parentheses divide by 2 equals 2 and it's paramagnetic.